Why does each electron have the same amount of charge? It is assumed that not all electrons are equal in amount of charge. Suppose there's a place in the world. The electron there has a charge of 1.5 times e. We'll use a pink rectangle to represent this place. The blue rectangle represents our normal living environment. We move electrons with 1.5 times the charge into our normal environment. It's going to divide its extra charge equally among the electrons around it. But there's a problem. Why is the charge of a positron equal to the charge of a negative electron? These three balls represent the electron, and the red ball in the middle represents the positron, which could also be a proton. That particular electron with 1.5 times the charge, and the moment it moves and it's going to give its extra charge to the protons around it first. The proton then divides its extra charge equally among the negative electrons around it. This hypothesis can explain our previous two problems. At the same time, it also explains that the charge of the same electron in the same place at different times is not fixed, but there is a range of fluctuations. But what is the variable that can change the charge of an electron? This yellow ball represents a negative electron. The yellow arrow pointing from outside to inside represents its electric field. The red ball on the left represents the positron and its electric field. Let's say they're transferring charge through an electric field. So if we apply a passive electric field around the negative electron from the outside toward the core of the electron, does that change its charge? We can generate a passive electric field through a changing toroidal magnetic field. A toroidal magnetic field is generated by a toroidal coil. We also need the Biot-Savart law theory to calculate the strength of the magnetic field. B0 is the strength of the magnetic field. B is the magnetic induction. R is the radius of the magnetic material. The section in the video is a rectangle. For a detailed description of Biot-Savart law, please click on this link, and I won't go into too much detail here. Then it is time to start calculating the strength of the passive electric field. Here we need to use Faraday's induction theorem from Maxwell's equations. Following are examples of the use of Biot-Savart law and Faraday's induction theorem. The above are just my assumptions and ideas, which can be overturned at any time when the hypotheses and experiments do not match. And finally, I want to add a test. If you take this particular electron and combine it with a hydrogen ion, it's more likely that it will produce a free neutron rather than a hydrogen atom or a hydrogen molecule.